from the FS Garage. Several years ago, we were approached by a company that makes drones to simulate one of their upcoming products while it was still in the process of being designed and manufactured. The lead time on such a product is 6 months or more, and they wanted to validate and tweak the design ahead of time and begin working on the higher level software using a simulation. In order to validate their design, we had to create a physics-based simulation that accounted for the weight and shape of the drone, the power available through each of the motors, and the thrust produced by the propellers they planned to use. We also simulated the amount of power drawn by the motors so that the lifetime of the proposed rechargeable battery could be determined, and we even simulated the sound produced by the four rotors as they spun at different rates. In addition to simulating the physics and behavior of the drone, we also had to simulate the control software that would run on the drone once it was manufactured. This was where the simulation had the most value. The client was able to tune the PID control loops that controlled how the drone behaved ahead of time, allowing them to bring the product to market faster. The drone had several different modes of flight that were simulated. In addition to manual flight, where the user would control the drone using a smartphone, they wanted the drone to have a face detection feature where the drone would automatically seek a nearby face and automatically position itself in front of the face and track the subject. In order to meet the face tracking requirement, we simulated computer vision by doing ray casting to find the user's virtual eyes and mouth. If all three could be seen, the drone would detect the face and fly toward it. Another flight mode it had was a waypoint feature where you could point at the ground and place a waypoint that the drone would try to fly to and maintain. Although the real drone had no such feature, it gave us an easy mechanism to determine if the drone was stable in flight and able to hold station without drifting. We implemented a mechanism that allowed them to switch to two different sized rooms. This was important as the drone was intended to be flown indoors, so it was important that it not be too difficult to control in a small space. It also had some collision avoidance mechanisms that were easier to test in a smaller room. In our original app, the client used a desktop VR system and shared the behavior of the drone with colleagues by inviting them to a meeting room where they could see what was happening in the VR simulation on 2D screens in the room. We've updated the original app to run on the Oculus Quest device and to use the Oculus Avatar SDK and social platform. This gives us a testbed to learn how to create collaborative experiences where multiple participants can all be in VR at the same time in the same environment and participate instead of passively watching one person through 2D screens. We hope this gives you some insight into how our simulation helped to accelerate the product design of the drone and bring it to market faster.